Hello, in this video I'm going to be talking about the decentralization of the XRP ledger, if there are safety issues or how safe and secure the network is, and also like addressing a little bit all the misinformation which has been spread on Twitter and social media. So first of all, the most important part about the XRP network, or at least about the decentralized blockchain technology, or well, it's called, or the XRP ledger, are the validators. These are the most important players in the entire ecosystem. So the first thing we're going to look into is onto XRP Scan. So that's also a pretty nice website. So if we go into validators, here are the most important validators there are. So currently in the DUNL there are 37. These are the players who decide which transactions shall work and which shouldn't, or which are denied, or whatever, or if there's faulty information, then they're deciding on nope, we're not going to allow that. So the first part we're going to look into that here is, like, for example, checking just the website I usually like to use commonly is the livenet.xrpl.org website, because on that URL you can see how the blocks are validated. I really love the representation here because you can see perfectly. So there's whenever a block closes, they're calling it, as far as I can remember, the last closed ledger, so the LCL. So we can see here the number 6349734. That one is the last closed ledger, and so on. So this is the entire core root of the consensus algorithm. So that's what happened. What is happening like every 3.8 seconds. So there's also a white paper you can download. It's by David Schwartz, Noah Youngs, and Arthur Brito. So you can look into it. I'm also not that well read into that. So I looked over it a little bit, tried to understand it. So they also have a little bit node theory and so on. So for the people who are interested, just enter Ripple Consensus white paper. You can download it, and that should be also like for those people who are like interested and to understand. So you can see here that also before defining the most important part, the server, the ledger, the last closed ledger, an open ledger, defining all of the UNL. This is also a very important part which I'm going to be mentioning, or actually I'm right now going a little bit into. So like I said, the most important player in the entire consensus algorithm are the validators. So currently there are 37, so we can see those 37 here, and also there's the quorum marked, so 30 is the quorum, so we need 30 validators to agree upon something, and we can also see them listed here. So there are these 37 validators. They are, like I said, the most important part. So all of these validators, each validator has a so-called UNL, a unique node list. So each validator can decide himself which other validators he wants to trust. So this validator trusts all the other 36 validators here, or 38, and each validator, so there are different entities running those, yeah? So we've got, for example, whatever, Rippleton.nz, Digifin UK, so there's one in UK, Cabitag, Arrington, XRP Capital, Blockdaemon.com. So you can also check it out a little bit. I think there's even a service, so just have to look it up quickly. XRP validator geolocation, if we can just look it up, where those are. I think there was like I'm just gonna look it up quickly if I can find it. Maybe not, then it doesn't matter. Well, there's also, we can see also the validator registry here, so I'm just gonna copy that quickly. So in xrpcharge.ripple.com there should be also validator registry, but those are not, well, let's see, maybe in topology. We can see it on the map here, hopefully. Let's see. Nope, this is just the topology itself. Nope, can we see the no? Ah, great. Yeah, we can see it there. So there are all the locations of the validators. But we have to be careful here because there are multiple validators run, and so those validators which are not in UNL, so not one of the 37 important ones, those do not decide. So we can check that out. For example, with xrp.coinfold.com, we can get the public key. We'll just copy it now and then look it up if it's in there, or maybe I had a typo here. Or maybe it's also in the list. It could be also possible. Maybe I'm just making a mistake here. I'm just going to try to copy the address perfectly. But Well, I'm just gonna try with another one maybe. Let's try with Rippleton.nz. But, well, I'm also going to open it here, then I'm just going to copy the public key again. So we can see here, for example, it's on the main chain. We can see that it's always in agreement with all the others, so it's not acting faulty or anything, and so on. So it's there always statistics like on each validator if they're doing the job correctly. So now, maybe I'm doing it wrong. So never mind on that. Oh, uptime, okay, no, it's fine. Okay, so I'm just gonna continue now because I didn't check the list before. But as we can see, oh, network validators. There should it be, I guess. Go to registry here. And okay, it's cut off here. That's where I can find it, I guess, isn't it? So I'm just gonna look into the HTML quickly. No, there's an entire string actually. It should be able to find it, but like I said, never mind. So what I wanted to look into a little bit now still is like, so let's just again look at the topology. So they are decentralized. We can also look a little bit closer at the entities running it. We've got, for example, Cabot tag. We would have to, for example, just check out the website, and we could also do a who is DNS. We could also do it who is request, so we can see who, for example, runs that domain. So we can also enter that one here. I have to do the damn capture. Come on. Okay. So you can always there are like authorities for DNS. So we can see, for example, that one here is so registered on GoDaddy, and it's, for example, here Michigan. So we've got it here in Michigan. So Cyprus, Michigan, Cavitac. So we could also look it up, like what the organization actually is. So okay, yeah, we spoke network and service design. Okay, yeah, so stuff like that, for example. So you could look up all the 37 validators, alloy.ee. You could also look at that one here, or at least the domain, what they're all about, alloy networks. So they're also run in Estonia. I think I just read that there. So you could go over all these 37 validators, and there's one being run by Ripple. And then you could still go over those, and Ripple is just running a tiny percent. We've got Bitso here running it. I don't know, I think Bitso is an exchange and also using it. So Bitso itself has a huge interest that the system works properly. So that's the brilliant thing about it. So people are running validators also out of self-purpose. So because they want that the system was working properly, and it's not very expensive to run a validator. So we've got Pure Island, for example. So the main point I'm trying to make here is that not all that like Ripple itself, the Ripple Labs Incorporated, the entity, the company, just runs a tiny percentage of validators and doesn't even come close to 80%. So it's like, I don't know, I didn't really look that closely right now into it, but I think about 5 to maybe 10%. So I would have to go through the entire list and check how many are running the are from Ripple on the DUNL here. But all in all, so this is the first point I want to make here. It is decentralized, so it's not controlled by a certain authority. Also, like just a few days ago, I don't know if you know the person. He's called Wietse Wind. So it's a person from the Netherlands. He also suggested a change to the UNL to a unique node list, and it was also a perfect point. Ripple is not publishing this list, so they did at first. So in their default implementation, they offer a unique node list, but the network can agree upon to add new validators to the system. So that's completely in the power of each validator, and all of them have to do the same, otherwise it won't be added. So I'm just going to quickly look it up, because there was just a tweet of Wind just a few days ago. Yes, there was a thing. Yes, it was from the XRP. Oh, my bad. It was from the XRP Ledger Foundation. So they posted something here. So we can see here the XRP Ledger Foundation is happy to announce that we have published a unique node list for the XRPL at the end of our URL. There are some differences between our URL and other widely used URLs. We have added two long-standing members of the ecosystem during URL. They added GateHub and Tovo Labs. By the way, if you don't know who Tovo Labs are, they were doing the XRPL toolkit. So you can see down there, that's Tovo Labs. They also made the XRP toolkit. And the other GateHub is an exchange, also supporting like sending GateHub euro and US dollar IOUs. And the one they removed is the validator from XRP chat, as we can see here, since we also have removed one validator as per public announcement they made about not running a validator with effect from 24th May 2021. So there's also a website called XRP chat. So it's basically a forum where people can just post and exchange ideas and all of that. You can see here the technical discussions, and it's widely being used, I guess. And so now let's quickly look into the UNL. So we can see here that it's base 64. It's an encoding, not an encryption, is commonly misrepresented, I guess. So we just can copy that. Then we just base 64 decode. We can add it there, so you can see formatter. So it's humanly readable. We enter it here, say process, and now we can read it calmly. So we can see here the validator public keys. So for example, we put here the first one, and so on. This list contains here, like I said, 30. So they mentioned they added 2 and 1 is gone. So we had before 38. -1, 37, +2, 39. And now all the other validators have to add that. So I think, as far as I'm concerned, I guess many validators already removed the old validator, because we're currently only seeing 37 here. So now you can see again, so it's done, like validated, because it used to be 38 just a few days ago. So I guess they already removed that one from the UNL, and now they have also decided if they want to add those. So it's upon the validator, the person who's running the validator or the organization, whatever, to do that. So they obviously think carefully about it, since it's not a small deal. So continuing here, so what are the attack vectors? Since many people are talking about ways to attack the system, and oh no, what if I suddenly start adding 20 validators to the system, or whatever, or 100, and it's easily 51% attacks or stuff like that. So you can see that on Twitter quite a lot. So also want to add clarity here. Also, why are there more validators? The answer is easy. So many validators are also here and also participating. So they're not, their votes do not count, but they're also here about being checking if they're acting properly, and if they're a long time here, and also like validating properly, working properly, and so on, they might earn the trust of the current UNL validator. So that validator might, for example, also be added as well. So it's more, as we can see here, the agreement at first was 94.06, and if they're behaving properly, they might be added to the UNL. So they're also like is a scoring mechanism, or they can also like check with the data if it's always acting properly, and so on. We've got, for example, also many other validators running here, and also some, for example, XRP Code, XRP Cove, XRPS, CS Jurgen, Edu, so Edo. So we've got some universities, I guess, there. Also wanting to run a validator, so they might be, for example, also trusted. So if we just check out the website, so okay, yeah, it's just a basic website in there. Okay. Oh, wait a second. I'm just gonna go onto it again because it was a subdomain. Because I actually wanted to go just to, so CS obviously for computer science, I guess. Oh my gosh, I lost the tab there. Well, somewhere there, I guess. Nope, I'm just gonna do one more time. So xrp.cs, there it is, okay. Oh, okay, it was already there, but I want to go into the URL. So we've got here the first part, so we're just gonna remove the XRP. So cs.jurgen.edo, so CS for computer science, I guess. So we can see now the official website, so computer and information science, yep. And it's the actual University of Jurgen, maybe also running an XRP validator. So they're not in the consensus involved yet, but like I said, they might be added, and well, I guess universities are also to some extent trustworthy of being responsible for that. Also, like at least having like good professors in computer science, and maybe also some DevOps specialists and so on. So yeah, it might be also like a good addition here. So now let's go to the attack vectors, because like I said, there was lots of misinformation out there, and also I might even show you shortly a tweet of David Schwartz. So I don't, probably, so if you're asking yourself who's David Schwartz, he is basically the father of the XRP ledger, so he's also on the RIP consensus white paper there, so you can check it out. Oh, and yeah, this is private email, so I guess please don't spam him. So we can see here David Schwartz, like I said. And so I'm just going to show one tweet because it was making a good point there. since he was basically retweeting the fact that we've got here, this is really significant, a validated UNL unique node list published by the XRPL Foundation XRPLF with overlap but not equal to UNLs published by Ripple and Coil. So it's about, like I said, they did a change to UNL, added something there, and he's saying there further proof that anyone, not just Ripple, can choose and publish UNL for the XRPL. And that's a good point he was making there, since it's not Ripple deciding which validators they want to add or not to add. It's rather in the hands of the people running those validators to decide who they want to trust. So now let's go to the attack vectors, because it's great. So there's all the information out there. They're publishing it on their information. So xrpl.org/consensus protections, and they're going on to all the things here. So for example, if certain values are misbehaving, then for example, we can see here accidentally sending confusing malformed messages, intentionally behaving with intent to defraud. So for example, sending faulty transactions, saying yep I want, or they're trying to spam them, we can block it. So if let's say that one of these values is misbehaving, and there the main point is, as long as less than 20% are misbehaving, everything is fine. Since we need to quorum currently of 30 to sign the transaction, so to let's say agree upon a transaction. And you see here the quorum, and currently everybody is in total agreement. So we've got always 37 out of 37 votes up for the entire transactions here. So yes, so let's go on to the next attack vector we've got there. So exactly, and what happens if more than 20% of the network are misbehaving? Then the network halts. So the network is not doing transactions, it's halting, and now it's the turn of the people who are running a validator to update their UNL. If, for example, like I said, 21% misbehaving, and suddenly all of these 21% nodes are actually intentionally trying to defraud and stuff like that, they can just remove those and run the system again with few validators, and then probably other people would have to start adding validators, or companies or whatever, or universities, and I could add those then. So, right. Then what else is there? We've got here, for example, software vulnerabilities. Okay, like I said, the code is open source, so it's on Rippled. So it's actually pronounced Ripple D, so DEE. So that's what I read in the documentation there. So you can everybody can look into it. They have also like good quality assurance system. You can look into it a little bit closer. You can also hear the releases, obviously. So it's GitHub for all the people who know a little bit about programming. It's just a tool for storing basically all the code, and people can add push codes, do commits or do pull requests, and it just updates. So it's just a management system for code actually, and a review system. So people can create issues and tell, for example, that there's a bug in a version 1.7, that there's something to be fixed. An unusual wrong offer node created. For example, there's one stuff there, and they want to look into that, how it happened, so the steps, and so on. What else do we have here? A Sybil attacks. I hope I'm pronouncing it correctly. A Sybil attack is an attempt to take control of the network. Exactly, that's the part. Many people think like it's super easy. Yeah, the UNL node there's only 37 validators. It's super easy. I'm just gonna do 40 or whatever. Well, actually, to get 80% consensus, you would have to run like, for example, 160 validators. Since we've got 40 and 160 is 200, and 160 is 80% out of 200. Okay, so I hope the basic maths are like in place and you know what I mean. And the thing here is that, so yeah, it's pretty simple. So this sort of attack is theoretically possible, but would be very difficult to accomplish because human intervention is necessary for validators to become trusted. So like I said, if these 37 validators want to add somebody else, each of them, so the certain, whatever, DevOps engineer, the certain person who's in charge of the server in the respected company or whatever university, would have to add it manually. That means that all these 160 validators you would need for get the 80% validation to submit 40 transactions would have to be like become trusted. It's like I said, it's like not very likely at all. No matter how many validating servers a would-be attacker runs, those servers have no say on what the existing participants consider valid, unless those participants choose to trust the other attacker's validators. Like I said, it's unimportant what all the other nodes are or validators are saying here. So it's the only important part of the first 37. These are the validators. These are the systems that have a say in the mainnet. All the other ones are helping. They are important. There are multiple modes how you can run a validator. So they're like it's on the XRPL server mode. So I'm also gonna open that quickly. So for the people who like also the technical details, it's on the server mode. So we just have to Google that quickly. And there are the server modes. So we've got the Ripple server there, and there's also like a subsection like server modes, I think. Nope. I'm just gonna do it one more time. XRPL server modes. Server modes. There it is. And we can see you can run a Ripple D server as validator, as API server, provides API access. So API interfaces are like places people can send requests to, and for example extract like transactions, like what were the last 20 transactions that happened. And also hub server relays messages between many other members of the peer-to-peer network. So these are the three modes. There's also apparently we've got the P2P mode with one of those, the reporting mode, and also standalone mode, an offline mode for testing, and so on. Okay, so there are multiple modes how you can run a validator. So that's also what some of them might be doing. So I already explained the amendments. I explained the fee voting. And so now let's go to last attack vectors we've got there. So we already also ruled out that this is a Sybil attack is unlikely. Like I said, like a single person or group of people just pulling up like 160 validators to take over the system. Yes, it's the XRP is decentralized and stuff like that. So like I said, that is also highly unlikely. So yes, so let's go into the 51% attack. So that's something most people of you know already, or at least have heard of, regarding the Bitcoin and Ethereum network, because that actually can work there, since anybody can start a miner for Bitcoin or Ethereum, so anybody can pull them up. So as long as a person controls 51% of the network, for example, of Bitcoin, or if it's also concentrated in a country, and government or so on could get control of all of that, they could easily, like I said, 51% attack blockchains like Ethereum or Bitcoin. But it's an attack on a blockchain system where one party controls more than 50% of all mining or voting power. Technically, the attack is slightly misnamed because any amount over 50% is enough. The XRP ledger is not vulnerable to a 51% attack because it does not use mining on its consensus mechanism. Next closest analog for the XRP ledger is a Sybil attack. Like I said, we explained the one before that the person would have to, like I said, which would be also very difficult to accomplish. Like I said, a person running 160 validators and convincing all the 37 UNLs to add his 160 servers, so validators. Right. So I hope I was able to like talk a little bit about the decentralization on the XRP ledger, make things a little bit clearer for you, so you can a little better understand. So I myself, I cannot guarantee you that I hopefully presented everything 100% correct here, but I'm also quite so I was doing it to the best I can and to my understanding. I might be wrong there and there, but overall I think I summed it up rather good. So if at least you now know how the validation works here, who are the important players there, and also what I also would like to highlight is running a validator is not very processing intensive. So I can also quote it there. So because there you can also learn how to install a Ripple D server. So we've got here, okay, now it's under concepts, but basically under the section install, I'm just going to go to get started again because there's multiple subsections there. And okay, now there it's not like the programming reference. I don't want to do. I already played with that as well, but I don't want to use it right now. I would rather look into the Ripple D server, Ripple D server, and I'm again there. Damn it. Okay, so I'm not able to find it. I will try to Google one more time. XRP ledger install. There's a guide of. Oh, okay, not XRPL ledger install. There was install rippled. Yeah, I think it was there. Exactly, there it was. So it was under tutorials there. And they're also here mentioning like that it's system requirements. There was even their own section. Yeah, as you can see the system requirements there. And you can see here a Ripple D server should run comfortably on commodity hardware to make it inexpensive to participate in the network. At present, Ripple recommendations, so we can see the minimum recommendations. So it's basically So they're also mentioning it down there that it's like it's resource expensive as running a mail server thing. It's not down there, but yeah, I also want to highlight that it's not that expensive. Like for example, with the entire proof of work concept, that one is very processing expensive. So and with the Ripple consensus algorithm, it's not the case here. So it's also like I said, there are the players. You can see they're right now validating 41 transactions in 4 seconds, and again 38 transactions validated within 4 seconds. And these numbers are not possible on the Bitcoin or Ethereum network, and also on any other proof of work network. And right, so this is very important to highlight. So that's the thing here, and you can also scale the so currently the XRP ledger supports up to 1,500 transactions per second. So I'm referencing their website right now, but they can also scale it up. So I guess using better hardware or also like stronger hardware and so on. So that should be also a problem compared. So I hope you do know how many transactions per second Bitcoin and Ethereum can process. So I'm right now recording from my head. So Bitcoin can process up to 4 to 8 transactions per second, which is basically nothing. And also the Ethereum network can only also we could look it up. So I don't know if you've looked at it yesterday. The fees were yesterday for Ethereum ridiculous. So the network was congested, and they were charging 160 euros for one damn transaction. I couldn't believe it. So like I said, it's not that sustainable. So they might change it. That's why why Ethereum is trying to get to proof of stake. And now there's a question how fast they're doing that, since apparently I heard that they are known for delaying stuff, so that it might take even longer, or that it's not clear, that nobody can really say when this is going to happen, and so on. So I do hope that you liked the video. I hope I explained everything clearly. If you have questions, you can leave obviously a comment in the comment section. And see you next time.